slide is not coming up. Oh, okay. I'm going to talk to you on agroforestry systems for production of food and non-food systems. So this is a very short overview of some of the agroforestry systems that is found in European context. So I'm involved in an EU project called Sustain Farm, where we worked with agroforestry systems. So I'm going to give you a very quick overview. This shows the spread of the partners across Europe. As you can see, we're spread in different environments, and then we have different agroforestry systems in these environments. So this was to take into account that we have very diverse agroforestry systems to work on. So some of the benefits of agroforestry, I mean, as we have also seen the last presentations, the agroforestry has multiple benefits, and one of these is high diversity, because we can integrate food, trees, and livestock for production of diverse products, and enhance productivity. As you can see, we can also enhance the yields by having different species, and due to the complementarity in terms of use of soil, water, and nutrient use. And we can also co-produce a diversity of food products. And this would also give us multiple income streams. Agroforestry is also known for a provision of a suite of ecosystem service, which I will get into a little after on how we did our quantification and valuation of ecosystem services. So here you see a brief overview of the systems that we worked on. So you can see here, the first one is a combined food and energy system from Denmark, and then we have four systems from Italy on olive tree production systems, and then one from United Kingdom on silvopastoral systems, and one from Romania on silvopastoral systems. And then we have silvo-arable systems from UK and Poland, and agro-silvopastoral system from Spain. So I'm not going to explain this term, so I guess you know it. Agro-silvopastoral is where you have, cereals and trees and pastures combined, and same goes for others. So this shows a diversity of systems that we work on in this project. And a pictorial overview of the systems. As you can see here, these are really diverse systems, as I've just mentioned before. So, and these are some of the glimpses of some of those systems. And this is the system from Denmark, where we have alley cropping, we have biomass settler belts on the sides, as you can see, and the crops in between. This shows the same system where you have a close view of the biomass belt. This is a willow biomass belt, which is used for producing wood chips. And just to give you an idea of what kind of products comes out of this agroforestry systems, and what are the functional properties of this system. So as you can see here, in Denmark, we not only produce cereal crops in this agroforestry system, but also we produce willow, hazel, and alder, and some lucerne and clover. So these are diversity of products that's being produced. And below you can see what are the different combination of vitamins, minerals, antioxidants, and all these different nutritionally important products that is available in this produce. So, but I'm not going to go into detail. Given the time frame I'm jacketed into, it's only 6 minutes. So, and then this is another system from UK, where you can see a whole range of cereals and vegetables, and then a couple of fruits there, and some dairy products and wood products. And then what are the different functional properties of these products? So this gives a overview on like what are the different systems that can really give diversity of products, but also diversity of different food with functional properties. So this shows some of the assessments we did in this project. So as you can see, so just if you look at the last column, there you can see the land equivalent ratios of different systems. So land equivalent ratio is a ratio that we use to measure the productivity of agroforestry or intercropping systems compared to monocropping. So when you say 1.36, I mean intercropping is 36% more productive compared to monocropping. So this is what it means, yeah. So as you can see, in all the systems, in Denmark, Poland, Italy, United Kingdom, and in Romania, you can see all the systems, the land equivalent ratios are higher than 1. I mean, because 1 is kind of the reference for monocultures. So this shows that the agroforestry systems are productive and they produce a wide range of products. We have talked a lot about ecosystem services. I'm going to drill down a bit on how we actually quantify ecosystem services. So this is one of the paper that I have written with my colleagues in my research group, which you can go in and look into. This is an open source paper. And so what we did was we quantified what are the products that can be marketed and what are these services that cannot be marketed. So if you go to the next page, here you can see here a whole list of provisioning services, regulating services, supporting services, and cultural services. So there's a whole range of services that we get from agroforestry system. And if you look at the last 3 columns, I'm sorry, I cannot, I think the pointer is not working. So I cannot really point it out. Okay. So if you look at the last 3 columns there, the CFE is the combined food and energy system that I just showed you, of the agroforestry system from Denmark. And then the next one is the conventional wheat, which is the wheat produced in a very conventional method with a lot of input of chemicals and fertilizers. And then the last one is the beech, as a managed beech forest. And this study has been done in Denmark. And if you go down all the way down to the last 2 rows there, so you can see the last row says non-marketable. So this shows the ratio of non-marketable value of a production system. So in that way you can really see what is the ratio of marketable to non-marketable or non-marketable to marketable. So, but here you can see, if you read the last 3 numbers on the last row, so it's saying 25%. So you can see the 25% of the value of agroforestry system is non-marketable. This is something which you don't count. And this we're talking about carbon sequestration, soil erosion prevention, pollination, pest control, soil formation, a whole range of ecosystem services which we actually don't count, but are the main supporting services that supports our agriculture productivity. And as compared to conventional wheat, where you can see there's only 12% of the whole range of ecosystem services that you get from conventional wheat system is non-marketable. And whereas in forest you can see 45%. So the main comparison here is between the agroforestry, which is 25, and the conventional wheat, which is 12%. Just to give you a brief picture on, we should, I mean, it's very important that we need to count the total ecosystem services for our product system in order to keep our production system and our soils productive. So what are the next steps to reaching the impacts in terms of encouraging farmers to go for agroforestry? So here are some of the brief points I put in. Demonstration sites for farmers and for advisors, policy briefs to the national and international lobby groups, training on agroforestry to the agriculture advisors, and the communication and dissemination to the farmers in a farmer-targeted magazines, and also to reach the local politicians and create awareness on agroforestry benefits. And like the one I did I mean, these are real numbers you can actually present to the politician and say, this is what we get out of agroforestry as compared to conventional monocropping. And also train and core, I mean, group of trainers in order to train on agroforestry and exchange visits among farmers on agroforestry and add value to the stream of waste that comes out of agroforestry because of the multiple enterprises we have. And also to integrate multiple enterprises in agroforestry. I would like to just give you a brief introduction to another project that I'm working on. This is an EU project on water and nutrient retention in arable production systems. And this is a consortium of European countries and 2 North African countries, which is Egypt and Tunisia. So here we are looking at how what are the nutrient and water gaps in these systems so we can produce nutritious food, in this system. So we use a mix methods of modeling and multilinear programming approach to find out what are the gaps in the systems and how do we solve this. So it is very innovative in the sense that we use similar tool in order to resolve the issues in this diverse environment, right from Europe to North Africa. So this is the spread of the partners I've just told you, and with this I would like to acknowledge the partners of this, which is EU and the Factory Surplus, which also gets money from EU. Thank you very much.